So let's begin with the emission decal. I don't think many people understand the importance of this decal. I always am sad when it's missing from the vehicle, because up here I can determine engine size, or somewhere on the sticker, right? This is a 5.3 liter. It's a 1999 model year. Sometimes they even give you spark plug gap. Not always, but this one does. That's nice. What I'm really after is up here where the word catalyst is. And underneath that, can you make out where it says SFI, or sequential fuel injection? EGR, this has an EGR valve. Okay, this tells you the emission components on the vehicle. It has a O2 sensors, one for each bank. Sometimes they'll say 2H2OS, heated O2 sensors. They're heated. And a TWC, or a three-way cat. It means it fights both three things: oxides of nitrogen, carbon monoxide, and hydrocarbons. Three ways, or three things it fights. Okay? All right. So information to know about the vehicle is always valuable, and that's a great place to start. This, of course, the one thing I wanted to emphasize here is that this is an O2 sensor system. It's not got an air-fuel ratio. Of course, in '99, there weren't too many air-fuel ratio sensor systems even in existence. Okay, what I want to do next is talk about one approach to understanding or seeing if a vehicle has a misfire. I'm going to start it up. I don't even have to have a scan tool or anything like that. Normally, I come back to the tailpipe. You can tell when a vehicle drives by if it's got a puff to it. Okay, this is nice and smooth. To show that, I'm going to show this little dollar bill. Nice, smooth exhaust flow, right? Well, what happens if I generate a misfire? And to do that, I'm going to come up here, get my lighting here better. I'm going to disable a coil. Okay? Disconnect one coil. This is coil near plug ignition, by the way. Spark plug wire down to the spark plug. Here's the coil. Coil near plug, they call this one. Only GM makes it, to my knowledge. Anyway, let's go see what that does to my tailpipe. I can hear it puff, 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 puff. Okay? Watch this. And that's what it's doing to the dollar bill. It's not a nice, steady flow anymore, is it? It doesn't tell me which cylinder it is, but I at least know if I've got a misfire. Use your ears, use your hands and things to kind of get an idea. So if I plug that back in, engine smoothened out. We'll double check, just to verify or just to emphasize my point. Here's my dollar bill again, nice and smooth. Okay? All right. That's one approach to at least identifying, is the vehicle operating on all cylinders? Because we know that there are three misfire types, right? If I could tilt my head down here. Three types of engine misfires. We have compression misfire, which we really can't fix unless you replace the engine or do some engine work. But ignition misfire, definitely can fix those, right, in a drivability class. And fuel, air-fuel ratio issues. Those can obviously be fixed in a drivability setting. Okay, let's identify a few things. That's part of what I really want to do today. And okay, to identify, the first thing I'd like to show is this EGR valve. Okay. EGR valve is, or EGR stands for exhaust gas recirculation, and this pipe comes down and goes right down to the exhaust pipe. Okay, we take some exhaust gases and actually route them, meter them with this valve. And here's another pipe that goes right up into the intake manifold. Kind of crazy, isn't it? We actually take exhaust gases and put them in the intake manifold. Well, we're doing that to fight one pollutant, and that'd be oxides of nitrogen. We're only taking in 5, maybe 10%, and it's only under light cruise speeds that we're actually doing that. We don't want EGR to operate at wide open throttle, cold engine, and let's see, what's the third one? There's 3. Wide open throttle, cold engine, oh, and at idle. It would make for a rough idle if that was to be stuck open for some reason. It basically only works warm engine cruise speeds, which we operate a lot in. Okay, the next this little sensor I'd like to identify would be the map sensor. Okay, is that showing up? I think it is. So this sits right on top of the intake manifold, manifold absolute. The next lab, we're going to talk more about manifold absolute pressure, okay? And here's the intake manifold, the upper intake manifold, right? The plenum, sometimes referred to as. But that's where the map will reside, somewhere on the intake manifold, okay? While we're here, let's now talk about this. Let me come around. This piece right here, this is the purge valve. It's part of the evaporative system, okay? Every so often, what's going on here? It's like things are backwards to me, okay? The PCM will tell this purge valve to pull the fumes that have been stored from the fuel tank. This system is basically a big vent for the fuel tank, right? And here's a dead giveaway. This little green cap, it was put there for testing purposes, which rarely happens by today's standards. But anyway, purge valve simply takes gasoline tank fumes and dumps them. The PCM will tell this when to purge and clean out the evaporative canister, and we burn up these fumes, these hydrocarbon gases basically, in with the rest of the air-fuel mixture. In the gasoline world, every car's got a evaporative canister purge valve, and that's what this is. Okay. Throttle cable. To access, I just want to access something here. This is the old school, right? And throttle cable. In fact, the newer systems that are not cable, obviously, that are drive-by-wire. This obviously is not drive-by-wire. That electronic throttle control system actually opens the valve, the throttle plate, I should say, more effectively and in a ratio that'll actually fill the cylinders with more air than the old throttle cable systems do. Okay, so this is still older technology, but what I want to point out is on the other end of this shaft is we have a sensor, and it's always mounted opposite the cables, and it's over here by the shaft, and it's always a 3-wire connector. What I mean by that is here we go. I'll pull it off. Three terminals, right? One of them's 5 volt, one's ground, and one's variable voltage or signal. And so that's my throttle position sensor. Now above the throttle position sensor, and every system still has these, we have our idle air control valve. This is an actuator. Idle air control valves, or actuators, are 4-wire. And two of these wires is power and ground to drive this stepper motor in, and two of those wires are to drive the little stepper motor back out. There's like 150 different, or maybe there's more than that, different possible positions little stepper motor inside can be, because this actually allows air to go around the throttle plate and dump into the intake manifold, and it controls idle speed. You get above idle, RPMs above idle, this is really non-functional or has no impact. But at idle speed, this is what's controlling our idle. When we turn on air conditioning, for example, it will ramp up idle RPM because the engine's under a load by simply letting more air get around and into the intake manifold to bring up the idle speed a little bit with that added engine load. Okay. Something else just for fun. Several manufacturers offer something like this. There'll be a little red post, and this is in a box. On this one, sometimes there's a red post somewhere, but this here allows you to a place for your jumper cables. If I can see where I'm going here. There we go. Allows a place for your jumper cables. Here's your positive one would go. Of course, here's a big old ear for your negative jumper cable. Okay, just thought I'd share that. One more thing. You see this piece right here on the cold air intake? This is a resonator. In fact, I'm going to take this completely off. I had this all kind of loose to begin with. Look at this. Air is coming from the airbox, right? And air, to smoothen out and make it more flow smoothly, they allow these little resonator or these little pockets for air to air pulses to kind of be absorbed to smoothen out the airflow and therefore improve airflow and cylinder fill. In other words, more air in the cylinders. That's what we're after, right? It's good drivability, more air in the cylinder. Okay, I'll just leave that there. I think we're through with, oh, one more thing. Let's point out this fuel pressure regulator. Okay, right here. Fuel pressure regulator. That's this silver thing here, if you can see that. It's a vacuum hose on it, quite common back in the 80s, 90s, okay, early 2000s. Manifold vacuum controls fuel pressure to some degree, maybe 5 or 6 psi if it changes all, but on acceleration, this would be zero vacuum, and it would bump fuel pressure up to have a denser fuel charge to the cylinders. On deceleration or cruising down the road, either way, you'll have 5 or 6 less psi fuel line pressure to the injectors. All right. This is a system that has a return line. So there's a line coming in, and there's a line returning back to the tank. Here's my in to the injectors, and what we don't need, the fuel pressure regulator allows it to go back to the tank and it lets the fuel actually cool off. That was a strategy they used to use. Today's cars now only have one line going to the fuel rail, and it's called returnless, and the fuel regulator is inside the fuel tank. Okay, let's come over here now to this Ford Explorer. Get some lighting, see a little bit better. Okay, let's talk a little about this Ford Explorer. All right. I think that's enough lighting. All right, let's find the emission decal. Okay, anytime I work on a vehicle, I really like to find out what am I dealing with here. And on this emissions decal, Okay, what I'm really looking for here. Oh, here we are. Don't know if you can see that or not, but it has AFS next to sequential fuel injection, next to the heated O2 sensor, next to the three-way cat. There's the AFS, or the air fuel ratio sensor. Maybe that's not as bleached out. That might be better. Okay, air fuel ratio system. Now this air fuel ratio sensor is just what we used to call an oxygen sensor. Okay, meaning down here is the oxygen sensor. It's an exhaust manifold, just like an oxygen sensor is. Coming up here, this one has 5 wires instead of the traditional 4. Many of these air fuel ratio sensors might even have 6 wires. In the Toyota world, they still have 4. I'm not sure exactly how that works, but that's what they do. But an air fuel ratio sensor allows us to stay in closed loop under a wider variety of driving conditions. For example, that old pickup over there, when I accelerate hard, it'll jump into open loop under hard acceleration before it goes back into closed. It allows it to add more fuel, just kind of dump it in to make sure I don't hesitate or have a starvation of fuel or power or performance. But an air fuel ratio sensor system allows us to stay in closed loop under a wider variety of driving conditions, and that's why they came out. Okay. Coil on plug. The other one was coil near plug. Coil on plug, of course, you undo the bolt, unhook the little connector, your spark plug's under here, you've done all that, you know what that is. Fuel injectors, right? Here's the fuel rail. Fuel injectors, plug into that, but this Ford EcoBoost, these injectors operate closer to 70 volt, not 14 volt system. It's a direct fuel injection system, and it needs more, much higher fuel pressure, like 300 or 400 PSI at idle. The old 99 Chevy pickup over there was probably closer to 40 PSI at idle, and never gets much above 45 ever. This one here can get up to, gosh, 1500 PSI. And there'll be no valve on the rail somewhere to put a gauge on there. That'd be way too much pressure for a gauge. There's often a PID for that. Okay. Of course, here's our single line returnless fuel system. It's got one line that feeds both rails. Okay. Here on this one is the charcoal canister purge valve. This hose comes off, and that goes back down along the frame, back to the fuel tank area, to the charcoal canister. So again, this is the purge valve on this vehicle. Okay. So this is not a cable throttle, operated throttle. It's drive-by-wire. Okay, it's got, I'll show another one I've got here just sitting here. Of course, it's got the little motor, got the connector, and much more accurate as far as being able to control air flow to engine needs in the cable system. We don't have to have a cruise control actuator system anymore because it can do it all electronically now. That's one more benefit. And we can detune an engine if the traction control system kicks in. This system will actually close down airways. It'll upshift the transmission. It'll do what it needs to do to help you get better traction and less torque to the wheels if you're spinning or having a wheel slip condition. Okay, let's see. I think we've talked about, the mass airflow sensor. Here's the mass airflow on this one. Of course, that's a real common place. Something to point out here is this. And of course, this one here, I don't know if I can get my camera to reach inside the hole very good, but here's my mass airflow sensor. You know what they are. You've had enough CAT classes. If we have a vacuum leak or air, a cracked air induction, you know, the cold air intake. Here's the resonators again on this one, isn't it? Aren't they? Anyway, if there's a crack here, see, this system is designed that the mass airflow sensor calculates air-fuel ratio in a controlled way, meaning what it senses here is what it's going to deliver fuel-wise. Okay? So if we have a crack in a, hang on a second, these automatic lights are driving me crazy. If we have a vacuum hose that gets a crack on it, and then here's another big vacuum hose over here. If we have a leak here, well, the mass airflow cannot account for it because it's only measuring the air coming through here. And if we have air entering the intake manifold somewhere else, or even a gasket, you know, we got a vacuum leak because of an intake manifold gasket problem, it's not going to deliver the system can't deliver the right amount of fuel because there's more air than is being accounted for, and therefore it'll cause the lean system, you know, provide a P0, 171, 174, you know, lean system code, that kind of stuff. So that leads me into one of our last topics to bring up here. And let's define where intake manifold vacuum actually resides. This is confusing to many. I'm going to start right here at the throttle plate. Anything beyond the throttle plate, okay, so this hose, this other hose back here, that's the PCV line, by the way. It's a big old hose that goes down the PCV valve. There's no other vacuum hoses we can really show here, but these hoses, or anything beyond this point, inside here is intake manifold vacuum. And our manifold absolute pressure sensor, the systems that have those, will reside somewhere on this or near it with a vacuum hose going to it. Okay? Intake manifold vacuum is present inside here, except under wide open throttle, then we're at atmospheric because we're letting so much air in that's atmospheric pressure. But at lower RPMs, definitely on deceleration, we have strong intake manifold vacuum readings. And my point is this: from this point out, any hose, now let's take this PCV hose for example, and of course that one hooks up to this cold air intake, okay, the plumbing on it. I don't have it all in place here, obviously. Whoop, goes like this. Anyway, this hose here is the clean air side of PCV system. You have two sides to a PCV system, all right? And this one here is just a clean air that allows fresh air to come into the crankcase while the PCV valve pulls air out of the crankcase under a vacuum. This is just a breather hose. If this came off, it wouldn't be a big deal. We wouldn't have a vacuum leak. This hose here, again, this is a purge valve, so I guess we could call it a vacuum hose because it gets a vacuum applied to it when the purge valve opens. But this car I can only show one breather hose, but you'll see other systems that have a few hoses coming off the air cleaner this side of the throttle plate, and that's going to be a breather, just allowing fresh air to get somewhere, no big deal. But from this point on is where intake manifold vacuum and hoses and stuff reside, and we've got to keep them in really good shape. Okay, we're going to conclude with a little clip that discusses what PIDs are. We've talked about some sensors, we've talked about some of the actuators. This, by the way, is definitely an actuator. It's being controlled by the computer, right? Air-fuel ratio sensor is an input. This is an output. Injectors are definitely outputs. Spark timing, spark control is definitely an output. I think you understand all that. But we'll end with a little clip in regard to PIDs. Just a little plug for the OBDLink tool. Okay. The performance
option is on the next screen. You have to go look for it. What's neat about this one is you can do a 0 to 60 drive. How many seconds? You can record this a quarter mile, 1,000 foot if you'd like to. Anyway, you can do the 0 to 60 and accelerate to begin. Kind of a neat feature. I've not actually done it yet. I'm going to go back to let's go to diagnostics and talk about PIDs, parameter identifications. In other words, these are each PIDs. These lines of data, right? O2 sensor voltages, short-term fuel trims, loop status. Right now we're in open loop. Key on, engine off obviously. I'm going to go ahead and show you how to just select other PIDs. If that can be seen, it's kind of washing out, isn't it? I'm going to go to SAE PIDs. And this is where I can select all the various parameters that I'd like to look at. The data, okay, data PIDs. Parameter identifications. Anyway, they're just a little basic thing about OBDLink. Kind of a neat little app.